morning, everyone. Welcome to Q2B. Thank you again for the QCWare team and Matt for organizing this amazing event. My name is Yuval Boger. I'm Chief Commercial Officer of QuEra. QuEra makes neutral atom quantum computers. And I have three distinguished guests with me. So why don't we start with introductions. Eric, so who are you and what do you do?
Is this on? Perfect. Hi, Dr. Eric Holland. Pleasure to be here this morning. I'm the General Manager of Keysight's Quantum Engineering Solutions team. So Keysight, you might be more familiar with us as Hewlett-Packard. So 80 years ago, Bill and Dave started Silicon Valley in their garage, and Keysight is the legacy today of that. So we're a team of engineers that really help to drive innovations and new emerging technologies, and quantum is the one that I'm peaked on. That's where my PhD is from. So thank you for having me here today.
And Nash, who are you and what do you do?
Hi, everybody. Good morning, and thanks for the invite. My name is Nash. I am the Chief Commercial Officer for Quantinuum. I spent about 30 years of my life in high-performance computing and AI. And so quantum is a new field, and I'm looking forward to seeing how we can have HPC, AI, and quantum work together to give solutions that can move the planet in the right direction, as our ambassador just said.
Wonderful.
Hi, おはようございます。
Good morning, everyone. My name is Nakadoi from Qemix. I am the only one speaking Japanese here in this panel. But quantum algorithm and software applications, we are a Japanese startup company focusing on these areas. From the beginning, we are developing algorithms specifically for FTQC.
So Nash, why don't I start with you? If you think about the most exciting news that happened in 2024, excluding news from your company, what would that be?
I'm assuming you're talking about quantum computing.
Yes, please.
Awesome. So, if I look at some of the exciting news, I can't just point at one. Right? I think the way that I look at it is, if you look at all the news that is coming out, what has stood out is the pace at which people are working towards new applications, especially, it's not going to come from the commercial side. It has to be driven from research, as Ambassador pointed out. The pace of applications that people are working towards has increased like 100x from when I was in my previous company. That is just last year. Okay, so I think that has been an amazing journey in the last 9 months, is to see the pace of application-based news coming out from every company. Right? I think everybody is doing their part to it. It's just not one company I can actually pull out.
Wonderful. In your perspective, what is the most exciting news that you've seen in quantum other than from your company?
First of all, the most exciting news that I have seen is the fact that I am here on this stage. That is the most exciting news to us. But beside our company, at the end of last year, quantum hardware vendors have announced very ambitious roadmap, and also high bit number machines are being launched into the market. And this is really exciting in this industry.
And Eric?
I'm going to be like most of the other panelists and not pick one thing. For me, it's been beautiful to see across the spectrum multiple quantum technologies continue to innovate going forward. So both your company QuEra and Quantinuum have both had fantastic years. You might disagree with me, but you guys have had some great advances. Hopefully later today we'll hear from IBM on some of the great work they've done on quantum low density parity check or quantum utility. So for me, what I've really appreciated is that there aren't any signs. People talk about being worried about quantum winter. I'm not seeing any real signs of that. There's consistent innovation going across multiple quantum technologies, and governments throughout the world are continuing to invest large in quantum. So at least from my perspective, there's a lot to be excited about, and we just need to be stay the course and be persistent, right? It's not going to happen tomorrow.
Is it okay if I answer my own question?
Yeah.
From my perspective, what was exciting in this year is the shift to on-premise quantum computers. We see several companies delivering and selling quantum computers for on-premise deployments. And of course, these customers would not be able to do so without, these companies would not be able to do so without the customers needing them. So customers are shifting from experimentation on the cloud to saying, we think this is truly strategic technology and we need to own a computer so that we have the resources, we have the control, and we can develop an ecosystem around it. Let me ask now a separate question. What is the most exciting news from your company?
はい、
Yes, for our company, as I said, FTQC is the target for our algorithm development. You may think this is great, but the algorithm, we had no machine that we can run our algorithm on. And this was quite frustrating. It has been in such a difficult situation for many years. But today, Quantinuum, we have a speaker from the company. We are utilizing H1 system. We were able to run our FTQC algorithm on a Quantinuum machine, and we have seen a very positive outcome. And our CEO, Matsushita, is going to give a keynote presentation. And this is an exciting news for our company. So thank you, Quantinuum.
Let's develop that. What is the most exciting thing from you, Nash?
I think, if I stand out, it's been 9 months since I've joined Quantinuum. And for me, the exciting part of it is to see where we are in terms of high fidelity. Okay, the advances that we have made in fidelity of a machine and making sure that as we add more qubits, the fidelity gets better has been extremely impressive, right? I think that has been a huge part of our development. And the second part of it is, the customers, right, actually coming to us and participating in this journey with us, right? You have seen some announcements that I'll talk about later in my talk. But I think just seeing the fidelity of our machines and where we have progressed has been amazing. And we'll continue to go on that path. And as we move and chart towards fault-tolerant computing. So I'm pretty excited about all the work that is coming out, and our team too. So,
Thanks. So for us, the most topical and geographically relevant is our MOU collaboration with AIST in Japan to work very closely on quantum technologies. As Nash was previously just mentioning on being very close to the users, that's where we learn the most, right? So we know with emerging technologies, we need to partner with leaders. So we're really excited to work on that going forward. I think we announced that publicly in June. It's been in the works for a while. So for me, it was a little bit of old news, but it was really exciting that I can now tell everybody else about it. So thank you.
Thank you. For us, since you mentioned AIST, so I would say two things. One, we announced a deal to deliver a machine to AIST, and we're very excited about that. I just visited the AIST site yesterday, measuring the width of the door and where the loading dock is and where the truck would come in. So all the nitty-gritty of delivering a computer, which is exciting. But the other thing that we saw in December of last year, together with Harvard and MIT and NIST, we demonstrated 48 logical qubits and algorithms running on that. And besides the excitement that that generated in the industry, what happened is that many customers came to us and said, we originally thought that quantum usefulness was going to be 5 years away. And we originally thought that results like the ones that you have been demonstrating would be maybe in 2 or 3 years. But given that you've demonstrated these results today, the timeline for us has compressed. So instead of 5 years away, maybe it's 2 or 3 years away. And therefore, we would like to engage with you and certainly with other players on this stage on developing applications that would be ready in 2 or 3 years to truly take advantage of the state of quantum computers. So that's what we're excited about for us. Now we're all here in Tokyo in this beautiful venue and amazing city because obviously we feel that there's importance to working together with Japan. So what are we all expecting from Japan-US collaboration and or more general Japanese companies with other companies outside Japan? So maybe I can start with you, please.
はい、
Yes, we are one of the Japanese software companies. Collaborating with European American companies is quite important to us. And also, it is important to partner up with Japanese companies. And we have to make sure that we are a good partner to overseas companies as well. Our strength tends to be in hardware area, or perhaps supply chain stability. But I would like to emphasize that we do have excellent technologies in software sector as well, and we can contribute to the development of quantum computing on a global level.
And with you, Nash?
Japan is very dear to our company, and Japan is very dear to me too. 30 years, I think what we see in terms of scientific computing and the maturity in scientific computing today has been driven largely with a lot of the advances which have been coming from Japan. And today, in Japan, you have the biggest system, right? The biggest single system on the planet, right? With 158,000 nodes, which are connected together as one system. Okay. The difference in the rest of the world is you have 10,000 nodes or 20,000 nodes. Okay. So the type of science that this machine is able to do, Fugaku, is tremendous. So I'm super thrilled, right, to have our machine working, together with Fugaku to drive new applications, okay, where we're going to have HPC, AI, and quantum work together. So lots of work which needs to be done. Okay, it is just the beginning. If anybody tells you, this application is going to be there tomorrow, it's not going to happen. But building the infrastructure to have hybrid computing is so important. Without that, you can't build applications, right, which have CPU plus GPU plus quantum working together. So I think Japan is going to be driving a huge part of this with the most complex system, which is actually working on the planet today. I think Japan should be proud of Fugaku, and I'm proud to be associated with Fugaku before and today, and with quantum computing. So I think that's where I see like the applications and the infrastructure, software and hardware for quantum computing to be a reality is going to come from Japan.
So Eric, I want to ask you actually two questions. The first one is, what excites you about working with Japan? And two, to Nash's point, I know that Keysight works on many different technologies. I had you and others on my podcast recently to discuss about that. Do you do any work related to HPC integration?
Okay, so I'll start with the first question, which is why we and I am excited to be in Japan. So Keysight incorporated a little over 60 years ago. Last year was our 60th anniversary in Japan, and we did that when we were HP entirely for a similar reason. It was to work very closely with users on emerging technologies. So that's very much in our bloodlines. Why I'm excited about Japan is a country that is both very humble, very innovative, right? The superconducting qubit was invented in this country. And then in general, Japan has done a fantastic job on leadership in public-private partnerships in quantum. So the university, national lab, and private sector in Japan work very closely together in a way that I believe other Western countries, if they modeled, would be all the better for. So for me, it's just been a breath of fresh air to see how collaborative everything is in Japan. So it's just a delight to work with the people here. They're not only world-class researchers, but they also have a very strong sense of community. So that was the first question. And The second question was on whether or not we do HPC integration. So that's not something that we've tackled yet in my team publicly. Keysight in general does, so as a company, there are parts that are very much involved with the latest wave of AI where low latency interconnects for HPC are all the rage because there's a lot of data that needs to be transferred around very quickly and processed efficiently. So that's something that we're very much keeping our eye out. And to Nash's point, the early innovation infrastructure jumps that need to happen, that's something that's very much on our radar.
So let me answer the Japan question, but also to my friends here on the stage, telegraph what the next question is going to be. So the next question will be, you can think about it while that's going on, is professionally speaking, what keeps you up at night? What are you worried about as you think about quantum computing? And while you think about that, let me just answer the Japan question. Japan, as others have said, is near and dear to our hearts. And I think the reason is that there's everything here. There is fantastic research done in universities. There is strong government support. There is a huge industrial base of customers that understand the strategic value of quantum. And that's why QuEra has been investing so much time and effort in Japan, and we're so delighted by the early fruits of our labor. So maybe I can ask that question about what keeps you up at night, professionally speaking. So maybe, Toshiyuki, we start with you, please.
So, well, quantum computers, right? And so today, well, the reason, well, what keeps me at night is try not to make trouble on stage. So, but as expert in quantum computers and hardware advancement, evolution leads to the commercialization. That evolution of hardware, whether that is feasible or not, is something of our greatest concern. And what keeps me asleep at night.
Answer is everything that's not in my control, because those are the things that I worry most about. More directly to your question, I'm not sure. So my background is an experimental physicist, so I see all the different platforms continually making progress on very hard challenges. They're meeting most of their milestones. That's going well. It's more of the things that I don't have as strong of pulse on, like investor sentiment. So earlier, Ambassador Emmanuel Ram was talking about AI. So AI came into vogue really quickly, and then if people decide that it's not providing as much value, right? So I saw an article this morning that 77% of frontline workers are finding AI to be burdensome rather than helpful. So a concern that I have is, oh, well, you know, if AI isn't producing as much as people had hoped, there might be some splash effects to quantum that we just can't control. Even if we're making great progress, there might just be some sentiment of, oh, advanced compute is great for scientific innovation, which is what Nash has talked about, but maybe it's not quite ready for the general consumer.
And Nash, how about you?
So, you know, I'm 57 years old, and I tend to sleep better, you know, nowadays. And having gone through all these transitions over the last, you know, 34 years, right, from seeing, you know, phones which were, you know, my first decade I worked at Motorola, phones which were basically analog, going to digital, and spending nights saying, you know, why is my management not building a smartphone, right? To worrying about, you know, my next transition was, say, why are we not getting a GPU out early enough at my next company? What I realized was things will happen, okay? And I'm being a little philosophical here. What I'm impressed about is seeing this audience here and seeing the investment in quantum computing in universities. Lots more needs to happen. Okay, I think about 1,000x investment needs to happen for quantum computing to come forward. Okay, my biggest worry, right, is that the countries are not investing in enough. Okay, going back to what Ambassador said, right, is when I was a DARPA product, okay, where I had 1,000 processor mass power sitting on one side and 128 processor KSR machine. Okay, this was in a small university, University of Cincinnati, and this was what made research in HPC and the reality of HPC happen today around the world. Okay, there's not enough investment. We need to have quantum computing, like you mentioned, the first thing, right? At the adoption, one computer is not enough. We need thousands or hundreds and thousands of quantum computers. And we are in the world of punch cards with quantum computing. If you really want quantum computing to become a reality in our lifetime, we need lots more investment coming in from the countries to put these machines in every university and community colleges. Okay? I'm not talking about our machine. It's any quantum computing machine, right, to go and develop algorithms. So the biggest thing which keeps me awake is there's not going to be enough investment. People may be happy with $100 million, $1 billion. That's not enough, right? This has to be in the level of what was invested with supercomputing, right? That's what keeps me awake, is quantum computing will take longer than I think it is just because of the investment from the countries.
So
but I do sleep well, at this time. So it doesn't keep me awake.
So as Bill Gates said, revolutions take longer than you think, and then they're larger than you think. Well, I woke up at 3 a.m. today, but it was the jet lag, not worries about quantum computing. But generally speaking, what we worry about is making sure that every country has access to whatever technology it finds best. We worry about barriers being constructed between countries, import controls, the ability of a customer to choose the best system for them as opposed to, say, the system that's made in the country that they're in. So that's one thing that we worry about a little bit. I heard someone say quantum computers are useless. True or false? And if so, why?
So there are people who saying like that. I don't think there are such person saying so within this venue. But on the other hand, I know there are general public who don't feel familiar with the quantum computers, of course, because that is one step beyond supercomputer. That is the image prevalent among general public. So the cutting edge research, for those who are engaged in such research, apart from them, maybe this is not so familiar with the rest of the public. But I don't think there is a person who thinks that quantum computers are useless.
I think it's in the eyes of the beholder. Okay, I'll give you another analogy. My daughter, she's 10 years old. If you give her an iPad and a laptop, right, she's going to say, I prefer the iPad. Okay, and the laptop is useless for her, right? But I think quantum computers are extremely useful for the researchers because they are going to go build stuff based on that. Okay, so the answer is, I think quantum computers are useless for the people, right, who can make good use of it. So the computer is useless for my daughter.
And Eric?
I'll go with they're useful. So in 2019, Peter Shor gave a keynote at the American Physical Society. I don't remember exactly how he phrased it, but it was essentially the quantum computers that exist today are useful to determine when and how and why they'll be useful in the future. So if you don't have these early prototypes, then you can't accurately predict when it's going to really matter to your organization, right? So say magically tomorrow we woke up and there was a fault-tolerant quantum computer that could break Shor's algorithm. There aren't a ton of companies in the world that would immediately be able to start using that device to start providing business value. There's a certain amount of needing to incorporate into your institution and build up that workforce to leverage it, right? So both the iPad and the laptop take a while to get all the utility out, and some people might never actually be good enough with a laptop to really get something, They might never learn how to code or video edit or whatever. So I'll go with they're useful. Not generally useful for the random person on the street, but they provide use.
I think quantum computers simplistically are useless in the sense that there's not much that you can do on a quantum computer today that you cannot do classically on a Fugaku or some other high-performance classical computer. But of course, they're super useful if you indeed believe that this is where the industry is going, that in 2 or 3 or 4 years, they will be able to achieve truly amazing feats. So walk before you run, crawl before you walk. So this is a time to get in there. How am I doing on time, by the way, Mr. MC? 1 minute, 2 minutes? Very good. So let me close with a question that I ask all my podcast guests, hypothetical. So if you could have dinner with one of the quantum greats, dead or alive, who would that person be?
I would have dinner with Planck.
And why?
He's very underappreciated, and everything that I've read about him in his biographies has been very pragmatic. So I just think it would be a very insightful dinner, right? I always enjoy having dinner with people that are able to succinctly poke at the very core of whatever problem you're thinking about, rather than somebody that goes on a long exposition. So for my style, I think it would be very enjoyable.
Nash?
Niels Bohr.
Because?
Because, I think when I was growing up in India, right, the Bohr's model was something that totally intrigued me. I never thought I'd be back to it after so many years, right? Like I said, 57 years. I think just seeing what he's done for, the field of quantum, and having had the good fortune of sitting at his desk and taking a photo also, I said, it'd be great to actually, met him and learn from, Niels. So.
And Toshiyuki?
I saw everyone who are here with us, and I'm planning to meet everyone with you. So today is the day. So let's have a drink later.
Richard Feynman. At the previous Q2B in Silicon Valley, I had the pleasure of having dinner with Professor Preskill. So I asked him that question. He says, no, I had plenty of dinners with Feynman. But then, of course, he wanted to have another one to see how he's doing. I think my answer would be Einstein, both, of course, an amazing physicist and a very, very good violinist. So I wanted to thank my friends here on the panel, Eric, Nash, and Toshiyuki. Thank you very much. And for all of you, have a wonderful Q2B.